Hey, what's up, guys? Chung here again. So, so this time I wanna talk about this LeetCode problem, number 939, minimum area rectangle. This is one of those like you can call it either math or geography problem. Since we haven't really talked about this kind of problem before, and I feel like it's a good time to discuss to show you guys what are some common approach for this kind of uh, geometry geometry problem. So with those kind of geometry problem, you're usually given like a set of points with the coordinates x and y, and then it asks you to determine like some areas or like how the numbers of the rectangles these points can form, right? And in this case, it asks you to find the minimum area of the rectangle formed from these points. Okay, so in order to form like, oh, by the way, so with sides parallel to the x and the y axis, which means you can only form like a rectangle parallel with x and y axis, something like this. Okay, right, something like this. Those 4 points, and there is also like a minimum area rectangle 2 problem. In that problem, it's the same question, but so that one is like it's not only parallel, so you can have like a rotated triangle, not triangle, the rectangle. Yeah, not triangle. You can have a rotated like rectangle in that problem, and I think I'll be uploading that videos maybe that video maybe tomorrow. But today, let's focus on this one here. Uh, I think in my opinion, this one is a bit easier than the other one because this one is only it's limited. So the constraint says you can only have a vertical or horizontal line here. Okay. Okay. So first things first, in order to find the minimum area of the rectangle, we have to find all the rectangles that can be formed with all the points. That's the first step. Okay. Mm, so I think there are like a few ways where you can do it, but today I think I'm gonna show you guys two ways of doing that. Mm, I think the first way is like it's kind of a brute force. Basically, mm, let's see. The first way is like let's say for example you have two points. Let's say you have 2 points here. Okay, and you have 2 points, and with these 2 points you have let's say this is x1 and y1. Okay, and this one is like x2 y2. Okay, so you have 2 points here, and since it's all the all the edges, right? All the side of the rectangle they're all like parallel to they're either vertical or horizontal. So with those 2 points, we can already assuming the other 2 points here. It's easy to find that, right? Basically, this point will be x1 y2, right? And this point it will be x2 y1, right? So the first way is we just loop through the we just fix two nodes first. Okay, we fix two nodes first, and then we will be looking for the other two nodes, the other 2 points. If we have find those 2 points, right, then we know, okay, we have already can form we can form like a rectangle, and then we just calculate the area of the rectangle, and then we just keep updating our answer. Okay, pretty straightforward, right? And yeah, but there is a little bit trick here to find how can we fix those 2 points, right? I mean, a, a very naive way is we just loop through mm, each point, right? Basically, we find all the combinations, and then we'll try to find the other 2 points, right? If the other 2 points exist in the current in all the inputs. But that will come a little bit slower, especially when I try to use that approach with Python. It gave me a TLE. I don't know why is that, because the length of this point is like only 500. So because that the time complexity for that is it's gonna be a uh, basically it's gonna be a 250,000. I'm not sure why it's TLE. So I mean, so basic because every time we're like basically looping through everything, right? In for to the point to find the other 2 points. And one of the improvements we can make here is we keep like a scene set here. Okay, so and every time we also loop through the nodes here. Every time when we finish looping through this point here, we add that to the scene node here. And every time when we calculate the area, when we're looking for the other 2 points, we only look for the scene sets. Okay, we're not looking for the entire point here, the entire array here. So with this one, so we are actually cutting the loop, the inner loop, like to a smaller set, right? Okay, so okay, let me try to code these things here. I'm not sure if you guys understand my approach. Basically, we're trying to fix 2 points first, and then we use those 2 points to look for the other 2 points. Okay, so I'm gonna have a scene set here, and of course we need the answer, right? Since we are looking for the minimum value, I'm going to define this as a maximum value, and then so we're gonna have a P1, right? The P1 and X1, Y1, okay, in the points, okay. And then for the second point, right? For the second point, we're only getting the second point from the scene set, right? It's x2, y2 in scene. So and then with those 2 points, right, we can look for the third and fourth one, which is so the third one is x, y, y2 in scene and x2, y1. Okay, it's also in scene. If that's the case, we know okay we have already find the area here, right? It's gonna be find the rectangle, so it's gonna be the x1 minus x2. We need a absolute value, right? Because the area is always like positive, right? Y1 minus y2, and then we just update the answer here. Minimum answer dot area, okay, and then we just add this. We just add the current node, current point to the scene set here. In the end, we simply return the answer here. We return the answer if the answer is smaller than the system, because it's possible we couldn't even find a single just one rectangle. In that case, we need to return 0. Okay, I think let's try to run this one first. Submit. Yeah, cool. So this one, it passed, and I think maybe some of you may have a question like what if since we're like fixing two, we are we are assuming those 2 points, the fixed 2 points are like the point 1 and point 3 basically, right? Because we're using those tools. What if what if those 2 points are horizontal, aligned horizontally or vertically? What's gonna happen? Let's say what if the P1, sorry, if the P1 is uh, let me draw these things here. What if P1 is here and P2 is here? What if the P1 and P2 they're on the same line here? Okay, right? Mm, I mean, if that's the case, right? So this is the x1 and y1. This is x2 and y2, right? So in this case, um, so in this case, the x1 minus y2, I mean, will be the same as x1 y1, right? So in this case, this x1 y2 will not be it's gonna be false, okay? Because we use this scene to verify that. Otherwise we will need to check if the area is greater than 0, right? Then we update. But in our case, I mean, since we have this check here, because when the P1 and the P2 are on the same line, okay, and the x1 and y2 they will be the same. It will be the same value. So and which in this case has not been added to the scene. That's why this thing is optional here. Okay, this should just also work. I mean, yeah. Okay, so mm, so basically that's the first approach by fixing 2 points, and then with those 2 points we can start looking for the other 2 points. Okay, yeah, and this thing only works when all the side are parallel to either x or y. Why is that? Because let's say we have these two nodes here, okay? Sorry, the 2 points here, and let's say the uh, mm, the rectangle can be rotated, right? So in this case, with those 2 points fixed, we cannot fix the other 2 points because the other 2 points can be anywhere as long as they have the same center. Let's say this is point 1 and point 3, okay? And this is the center point here. I mean, if the I mean if the rectangle can be rotated, so we're gonna have like infinite possible rectangles. I mean, as long as basically these things can be rotated. Let's say we have another one here. The this is the first one, right? basically this is going to be the P2 and P4, right? As long as the other 2 points can form like a diagonal line that has the same centers. I mean, these things can either can basically can move, right? This can move here, and right. So this is also like a valid rectangle. Okay, this is also a valid rectangle. Basically, we have indefinite possible rectangles if the rectangles can be rotated. And actually, that's exactly how we are going uh, to solve the solutions in the minimum area rectangle too. But in this case, since there's only with those two fixed points, there's only one possible rectangles, okay, which is this one, right? That's why we only need to fix 2 points, and then we can be sure what are the other 2 points we're looking for. And once we find those 2 points, we know then we can calculate the the answer, the area, and then update the answer. Okay, cool. So that's the first approach. Okay, and okay, another approach. Another approach is this. Let's say we have we have different dots here. Let's say dots here. Okay, come on, too big here. Uh, I'm drawing some dots randomly here. Okay, okay, here, right. So I'm just drawing some dots randomly. As you guys can see here, another way of doing this, and since they are like all aligned with either x or y axis, so to be able to form like a rectangle, so the rectangle is like this, right? Basically, so what we need to know, what we are looking for, another way of looking for a rectangle is we just need to find a pair of of the vertical line here. Okay, same here, right? We need to find a pair of the vertical line that has the same start and end point. Okay, so in this case, that's so these two lines, right? So these two vertical lines, they have the same start, y1 and y2, right? They have the same start and end point. As long as we have those two pairs, then we know the two vertical pairs, then we know, okay, those two pairs can form like a rectangle. Okay. Okay, so and we'll be using that to find the rectangles by saving all the vertical lines, basically all the vertical lines into a hash table, and then we'll scan the the vertical lines from left to right. Okay, so in order to do that, we need to pre-process, right? Basically, uh, we're gonna have like a hash table. The key is the x coordinates here, and the value is gonna be a list of the y coordinates. Basically, we're gonna store for each x, what are the the y coordinates on this x. In this case, we have two here, and here's another two, and here, right? So that's how we're going to store all those y1 and y2 pair, and we'll be scanning those from left to right. And every time when we have like when we're at this current uh, the current y1 and y2 pair, right? And we'll be looking for if the previously one have any has any the same the previous lines have any, if they have the same pairs, and if they do, then we know, okay, we find that I find a rectangle, and then we'll be calculating the rectangle, the area of the rectangle, and keep scanning. And another thing is that not only we need a hash table to store all the all the y coordinates for each x, we also need a second hash table to store uh, the last x-axis for each of the y pairs. So why is that? Because, for example, here, right? Let's say this is a 1, 2, 3, right? And this is a 1, 2, 3, 4. Okay, 3, 1, 2, 4. Okay, this is also 2, 4, and 5. This is also 1 and 3. Okay, because let's say we start from the first line here, right? And we have a vertical line is 1 and 3. Okay, and then when we are at the vertical line 2 here, right? The x2 here, we have a 2 and 4. And then we'll be looking for, okay, is this 2 and 4 exist in the uh previous like a hash table? No, it's not there. So we just keep doing it, okay? Mm, okay, and now we have this one. We have 1 and 3 here. Okay, so once we have 1 and 3, we check. Okay, so have we ever seen a 1 and 3 before? Yes, it's here, and the value is 1 here. And then with the current x3, we can calculate the area, right? And once we finish calculating this line here, since then we'll need to update. We'll need to update the last x for the line 1, 3 to the current x here, so that when we meet the line 1, 3 again, we know the last one is 3 here, because there's no point to use this 1 anymore, because since we are like sorting, because we sorted those hash table by the x axis. So, and x is always increasing, right? So there's no point for us to calculate yes, true that, this will also be a bigger a rectangle, right? But there's no point for us to calculate this area, because we know we have a smaller one here, right? That's why we only keep the latest x for the 1 and the 3, and we just keep scanning it. Okay. Hmm. Yeah, actually, there's another like a problem. If you guys are interested, I think it asks you to find same description, but it asks you to find the numbers of the rectangles, that all these points can form. Okay, so then can you, if you guys want to solve that problem, similar idea here. Basically, you also need to store basically store the vertical lines here. Okay, and every time when you see a new vertical line, you I think probably you also need to sort. You also need to sort the vertical lines. And every time when you see a vertical line with the same numbers, basically you just add. You just add two numbers. You just add you keep adding the count of the existing count of the same vertical lines here. So for example, here, when you see this one, right? So at the beginning, this thing is 1. And so when you see this like vertical line with the same 1, 3, you have a number 1. Okay, and then the second time you see the number, you see another one here, right? you need to add 2 here. Okay, right? Basically the 1, 2, and 3. If you see a third one here, okay, if there's another 1, 3 here, you need to add 3 here. Okay, that's how you count the number of the rectangles. Cool. Okay, so enough talk. Okay, let's try to code these things here. Okay, and all right. Okay, I'm gonna comment out this thing here. So like I said, oops. Uh, First we're gonna need to pre-calculate the y coordinates on each x, and how I'm gonna call it columns. Maybe columns not a good name. Okay, whatever columns, default, right? Dictionary list. Okay, and then for x and y in points. Okay, columns. Actually, it should be y coordinates. Y coordinates. Yeah, I think this name is more a more proper name. Um, X dot append Y. Right? That's how we initialize these things here. And what's next? Uh, yeah, and then we need to sort. We need to sort these things from smallest to the biggest. Okay, we need to sort by the x. That's why we're gonna do a x in sorted, right? We inserted the y coordinates. Okay, and yeah. So now we have a list of we have a y, we have a y list, okay, in the y dot coordinates dot x, okay, and we also want to sort this y list because um, I mean, we don't have to sort it. I mean, we don't have to sort it. It's just that, when we try to find when we try to find the list, the lines, right, the vertical lines here, we need a start and end, right? I mean, if we don't sort it, we could end up having like y2 dot y1, right, instead of the y1 and y2. That's why we want to sort uh, this list. Okay, so from the lowest to the highest, so that we're sure that the second one is always the bigger one, right? Second y is always the bigger y. So mm, now we have the uh, I and y1. Okay, y1 enumerate y list. Okay, we have the first y here, right? Now let's find the second y for j in range uh in range in range I. Yeah. Okay, so yeah, and here the y2 is the so y list of j of j. Okay, so now the y1 is greater than y2. Okay, so now we can see this basically if oh yeah, since we need to check if this the same y1, y2 exists, we also need like um, another hash table to store the vertical lines we have seen so far. Okay, it's gonna be the vertical line. Okay, vertical lines. How about this? Okay, basically, if the we can use either y1 or y2 as long as we follow the same sequence, it's fine. Basically, I'm using y1, y2 as a key. So if this thing is in the vertical scene scene lines, okay, in the scene lines here, okay, then uh actually here the key is the line value is the x coordinates coordinates. Okay, so if this line has been seen before, and then we can uh, calculate the area here. So here the area uh, is gonna be the what's the area here? So it's gonna be the current one. So current x minus the scene lines, the previously lines area, okay, y1, y2, okay, times what? Times y1 minus y2. We're not using the absolute value here because we're sure that now the y1 is greater than y2, okay, and then we have this. Of course, we need the answer here, okay. The answer is like system dot max size. So here we have a answer equals to minimum, okay. Area answer dot area. And okay, yeah, one last things. Every time when we find a lines here, okay, we'll be updating the lines because for the same lines, we only need to record the latest x, okay. So here, scene lines dot y1 and y2 equals to the current x, okay. Yeah, that should just work. And here it's the same return here. I'm going to copy this from the previously result. So this should just work. Okay, submit. Cool. Yeah, as you guys can see, this one it's faster because even though this is like a n squared solution, but since there are like a lot of mm, since there are like a lot of like lines here, right? I mean, the actually we're not looping through all the points here, right? Because it's like a 1.5 n squared, Yeah. Yeah, but anyway, the idea is this, right? I mean, uh, I think that the one thing you guys need to learn the one takeaway from this problem is that, the first approach is kind of okay. I think it's not that hard to come up with. I think it's the second one that the second solution approach you guys really need to remember or try to understand it. Basically, especially with this like parallel to x and y axis, we to find rectangles, all we need to find is a pair of the vertical lines. Okay, as long as we have the same pair of the vertical lines, we know we have found a rectangle. Okay, And that's exactly what we're doing here. Basically, we are maintaining like a x, the y coordinates for each x, and we sort. Okay, we sort by the x, and then for on each of the x axis, we loop through all the possible vertical lines on this x, and then for each of the vertical lines we have, we're trying to see, okay, if we have a same pair seen before. If there is, then we know we find another a rectangle. We can just then calculate the area. And then here, uh, we're always updating the x coordinates for this y1 and y2 because we are looking for the minimum one, right? So there's no point to store the previously x for this x y1 and y2. Yeah, and in the end, simply return. Cool. I think that's pretty much I want to talk about for this problem. Yeah, and I hope you guys enjoy watching the videos and stay tuned. Same thing here, and see you guys. Bye bye.